Hello, hello. Wait, is it working? Yes. Okay. Sorry, everyone. Wait a second. Let me set up. Okay. 好，我们把上投影机大家看得清楚吗？好像有点。我把前面的灯关掉。同学可以帮忙把前排跟前面的灯关掉。Okay, that's better. And okay, let's see. PowerPoint. Okay, that should be fine. Where is this? Very low volume. Okay, anyway. Yeah, this should be working. Okay, let's get started. So as you know, this course is Signal and Assistant, and we'll be teaching English and I guess the ordering of this is a bit weird. Wait, sorry. I think this is not quite I want. I want to change this to no. Will this work? So let me try to figure out the video. No, how do I? Okay, more. Yeah, this one. Okay. Now this should work. So it's small. Okay. Yeah. So this course is about signal and systems, and as you see, we will we will also have our course video or course basic stream on YouTube, and so there will be video recording. This is something I started doing during the pandemic, but I think people find it very useful, so keep doing this. And so I guess the ordering of this is kind of funny. Let's jump to the end. Ah, shoot. Another. Let's do the end. Okay. And this is very annoying. What's going on? No, not this one. Excuse me. This one. Okay. Yeah. So let's go to the organization first. So this is a textbook you probably already see on the school website. And yeah, that's the textbook. And and there are more recommended textbooks, but we will mostly follow this Openham textbook book, and the homeworks are basically all from the book questions. Okay, and we have kind of a planned schedule. Hopefully we can adhere according to it. So this is a plan, but up to change. Maybe I will go too fast or too slow. So we will go like first 6 weeks. So the first 3 chapters, then we'll have midterm 1, then 2 chapters. So chapter 4 is has more content, so we will spend more time on it. Then midterm 2, then last 2 chapters, and the final. And this is probably the most important course information here. So evaluation, it changed a little bit from what I had on the school website. So most of the points will be on tests. So midterm 1, midterm 2, final, so 20%, 30%, 30%, and homework still takes something, but it's only 15%. Okay. So you might spend a lot of time on homework, but I still think tests are more important. So most of the points are in test. And we have our course website on eLearn. So most information and videos and the lecture notes will be posted on eLearn. Also, homework will be on eLearn. And like homework solution will also be on eLearn. And like I said, we will stream our lectures on YouTube. So this is my YouTube channel. You should be able to find all the videos from past broadcast there. And homework policies, it changed from last year a little bit. So we will just do weekly homework. Makes things a little easier. So homework will be posted and collected on every Friday. And in principle, you should turn in your homework in class, and they will turn into the TA will collect. And this is our TA, Li Zijing. Okay. And you have, so he will be the one who graded the homework. And you have questions, you should probably ask Zijing also. Okay. And about late homework, policy is basically no late homework is just for make things easier. So I guess if you can coordinate something with Zijing, then maybe you can do a little late, but yeah, try not to do that to make TA's job a little easier. And also, because you might have like some emergency accident that, so sometimes you cannot turn in your homework. So we just have the policy like will tolerate one of your error. So one of the homework will not be scored. So maybe you just do really bad, or maybe you forgot, or you are sick, something. But yeah, the lowest one will not be counted. Yeah. And here are our contacts. So this is me, Han-Hsuan. So my office is just upstairs, 6th floor. And this is my email. And also our TA, Zijing, once again. Maybe Zijing can stay up. Everyone see you. Yeah. So this is Zijing. And his office is at the next building, so 445. And this is his email. Okay. So anyone has a question with the organization so far? And we have a pretty big class, but I think we are doable. So yeah. So if you are 加签, should probably, I already approved everyone 加签 this morning. That's in the system, but so I guess we can still take a few, because I think the only limit is how many people like we can fit in this class. And we still have some vacancies, so that should be okay. Okay, so it's almost auto battery. Okay. Anyway, so any question about the organization? And can you guys understand my English? Okay, kind of. Okay, I see someone nodding. Okay. Okay, then if there's no other question on organization, then let's go into actual stuff. Okay. So we are going to teach you about signal and systems. So what are signal and systems? So this is signal and the system. And signal is any variable that carries information. And what this means mathematically is that it's a function. And mostly it's a function of time and sometimes space. And think about function is something like this. So the axis is time, and the function and goes up and down. And this up and down is some information that you want to convey. And what is system? Now this is something more foreign. So system is something that makes the input function to an output function. So if you want to be technical mathematically, a system is functions on functions. So I make a function to another function. But anyway, that's a system. So system is a thing in the middle here. You will have an input signal, and you will make an output signal. So once again, remember signal, just as we say, is a function. So this is function, just like this function. This is a signal, and they will output to another signal. And this signal will output to another signal. And well, mathematically, this input-output map can be really arbitrary. But in this course, we'll do things that make more sense. That is, we will map the input signal to something that in the same form. Like you can see, we have an input continuous function, then we will map to a continuous output function. And discrete input function will map to discrete output function in this course. Okay? And yeah, so this is really important. You need to remember what are signal and systems. So let's get a little more mathematical with some more symbols. So as we said, signal is a function. And the function usually mathematically we just express like this. X of t is a function. X is a function of time t. Okay? Should be okay. And okay, now system is really confusing, kind of because of our notation. So as we say, system is something that maps the function to another function. So like here, we map this function x of t to another function y of t. And as you can probably see, this is a really confusing notation. This is just how we express the system. So x of t is the input signal, and y of t is the output signal. And where is our system? System is just this arrow here. Okay. So yeah, this is really confusing because we don't give a name to our system or something. So whatever our system is, we just write it as an arrow. They all look the same. But this is a convention for the course. And you just need to be careful about what is a system and what is a signal. Yeah. So once again, when we write a signal, we will often write this x of t to y of t. Okay. So it looks like two signals here, but we are really talking about a system. And anyway, back to system. So example of a system of this is y of t is the differentiation of x of t. So y of t equal to dx dt is a system because whatever input signal x of t you have, you can calculate this dx dt to know your output signal. Right? So this y of t equal to dx dt will describe the relationship between y of t and x of t. So you can use this system to calculate whatever your output signal is if you are given an input signal. Okay? So everyone okay? Question? This is important to remember what is the signal and what is the system. And don't confuse the two. Or even though the symbols, the notation of a system looks really like a signal. So sometimes you will see this y of t equal dx dt, but don't confuse this y of t with just a signal x of t. Okay? Okay. So that, and we have a small text here saying that this continuous time signal is just one of the possible signals. And we'll just see next slide. So as just say, there are many different kinds of signal. So the biggest two are continuous time and the discrete time. So everything we discuss are basically going to have two parallel sections about when time is continuous and when time is discrete. And in this very good symbolic picture, we'll just see, so continuous time signal is this continuous thing, so time is continuous and you have signal everywhere. And when discrete time, then time is discrete, and we take the convention that we take time only at the integer value. So you see the time are only the 0, 1, 2, 3, 4, 5, and the -1, -2, -3, -4, -5. Okay? So we talk about discrete time in this course, then the times are always integer values. Okay, so the spacing are always 1. And the notation we'll use will actually distinguish between continuous time and discrete time by the parentheses here. Okay, so if you have this parentheses here on your variable t, then this is continuous. And if you have this bracket here, then it's discrete. Okay, so continuous time is x of t, and discrete time is x bracket of n. And yeah, and usually we'll use n instead of t for discrete time. And just what do we say here? So continuous time, we use parentheses, and it can be not x, it can be x or y or z, and maybe we'll have even more variable, a of something, a of x, y. But for discrete time, we use bracket, and you see this x, y, z, now with bracket n, or we have more variable. Okay. Any question? No. And then let's just go through some physical examples. So what are signals? So some continuous time signal maybe in this circuit. So this electric system, then you have voltage, capacity, resistance, then there will be current, and there will be voltage everywhere, and those all depend on time. So those are continuous time signals. And maybe you are driving a car, and your car moves in one dimension because you are driving a straight line. And then your car will have location, velocity, acceleration. And from middle school physics, you know that if you differentiate location, you get velocity, and then you differentiate the velocity, you get acceleration. Oh, if you do differentiation, probably not middle school, but anyway. Yeah, so you see the location, velocity, acceleration, those are all signals. And there is some system to relay those three. Okay. And you can have your speech signals recorded somewhere, and those are also continuous signal. Those are probably the air pressure when you speak something. Okay, and so those are one-dimensional continuous signals. And you can also have discrete signal, and basically anything your computer record is discrete. So like this picture, when you record it so this black-white picture, when you recorded it on your PC, and I think we record this in BMP format, so it's just one value for each block, and you have value determine how black your block is. And so you write down all the number at the locations will look like this, so like a big matrix. So this is a two-dimensional discrete signal because you have the two-dimensional grid, and every location has one value. And you can also have this one-dimensional discrete signal, so like stock market index at the end of the day. So every day it goes up and down, up and down. And you can have more discrete signal, so like more image and or digital videos, because when you store video on your computer, you are also storing it frame by frame. So each frame is discrete. Okay. And now there's an interesting concept that we don't have time to cover in this class. That is, you can turn a continuous time signal to a discrete time signal by do sampling. And it's just maybe let's go somewhere. No. Okay. Yeah, it's just that if you have a continuous time signal, it goes up and down. So let me try this. Okay. So you have some continuous time signal, it goes up and down, up and down. And if you just sample it at the integer values like this, right? You just recall the function value and those integer value and discard everything else, then you will get the discretized signal. And there are some theorems that converting back and forth between those two, but as we say, it will be not in this course, but it's not covered in this class, but it's in the book, so if you are interested, you can read it. Okay. And oh, what's going on? Okay. And so one of the attributes of the signal is a dimension. And when we talk about dimension, we mean the dimension of the variable. So most of the signal we talk about will be one-dimensional because it depends on time. Okay, so those kinds of signal, they are all one-dimensional because we are only thinking about voltage, current, how they depend on time. And obviously there are 2 or 3-dimensional signal, like this picture, then it's 2-dimensional. But mostly we'll focus on 1-dimensional signal because most of the time we care about how our signal depends on time. And yeah, like we said, we also have 3-dimensional or 2-dimensional signals. Okay, yeah, theoretically. So those are a lot of examples of signal and what about system. And so we had a very mathematical definition of system as a mapping between a signal to another signal. But here is a more physical interpretation of system and kind of why we want to think about system. Well,